my name is Eric. I'm going to talk tonight about ML Kit. It's funny, I just needed another word to go with hype that started with an H. And I came up with the title at the top first before I came up with, and then I had to figure out what I was going to talk about that involved Hawkow. So you'll see. First of all, let's talk about what machine learning is. So that's the ML in machine learning. Sorry, ML stands for machine learning. What is it? You've probably heard lots about it. One definition that is widely quoted is that it's a field of study that gives computers the ability to learn without being explicitly programmed. This comes from a guy who wrote a paper in 1959 about how to teach computers to play checkers. And he taught it by just explaining coding the rules into the game, but not telling it how to strategy or anything like that. It just sort of told it here, this is a winning game, and he talked about the approaches of machine learning. So it has been around for a really long time. Another definition a little more recently from a guy who wrote a book called Machine Learning, and I paraphrased him here. He says it's concerned with the question of how to construct computer programs that automatically improve their performance at some task with experience. So to break that down a little bit, let's take an example of a task that machine learning is really good at doing. One of the most common ones is image classification. So that's identifying, is this a picture of a cat or a dog? So that would be the task. Performance is its accuracy at saying, if this is a picture of a cat, it actually says it's a cat. And for pictures of animals it's never seen, that can identify with some type of accuracy. And the automatic improvement is that the program isn't being taught by developers and iterating of identifying that, here's the difference between a cat and a dog. Cats usually have shorter snouts, or cats usually have longer tails, or rules like that. But it automatically, if you give it more examples of pictures of cats, pictures of dogs, it gets better at that. So it might seem like a trivial example, but consider this. These are pictures of chihuahuas and blueberry buses. And if you were a little far away or squinting, maybe you couldn't even tell. And so how do you teach a machine learning algorithm to tell the difference between these two? And the idea of image classification is that you just give it a lot of images labeled. Labeled just means you identify in some way. So it could be as easy as you have one folder full of muffins, one folder full of chihuahuas, and you just tell the algorithm, here's all those images, and it learns. Now I mentioned that you've probably heard about it, and that's because machine learning is everywhere these days. I just grabbed some of these headlines from the last year. It's not just technical and computer and programming blogs and stuff that talk about it. It's mainstream media about the benefits that AI is going to bring to our society, the dangers that AI will pose to our society. Where will our jobs go when everything is automated? Toronto happens to be a center of machine learning research. You may have heard back in March 2017, there was a place called the Vector Institute. It's sort of collaboration between academics and industry to sort of make Toronto sort of a center of machine learning. And Montreal is actually another a big center. There's a bunch of academic groups there doing a lot of work and a lot of startup companies. Okay, so back to the focus of the talk. I want to talk about ML Kit now and what Google is doing, why they're doing, and why they're bringing ML to mobile devices. Okay. So ML Kit was announced at I/O this year, and it is really at its core as a set of machine learning SDKs for mobile. I say mobile on Android because it's available for iOS also at full feature parity, and they're bringing their own 15 years of expertise in machine learning to developers so that you and I can use them in our own apps. Some of the things that that it's built on top of, and this is actually in the order of how you would think of a software stack. ML Kit's the application layer. TensorFlow Lite is the machine learning model layer, and the Lite suffix just refers to the fact that they've come up with a new file format that is optimized for mobile. And at the bottom is a new thing called Android Neural Networks API, which really is a low-level interface that hardware, NVIDIA or ARM or somebody can build drivers for their AI-accelerated chips to work and make TensorFlow Lite models faster. And the equivalent on iOS is the Metal API. Now, machine learning applications are challenging on mobile for a number of reasons that you could probably imagine. It's certainly not GPU enhanced or have a whole network of cloud servers running it. But Google's aim to bring ML Kit to everybody is that they've solved some of these hard challenges. So you need a lot of training data. As I was saying about the Chihuahua and the muffins, you need a lot of images, hundreds, thousands for the cloud models, even more, to get the algorithms to give you good results. Models that work well in the cloud don't necessarily work well on mobile because they have millions of parameters. It's just too much memory allocation, too much CPU. And a nice thing about putting it in Firebase is that they've integrated ML Kit with some of the other features of Firebase that you might use. A lot of machine learning is just experimentation. You want to try one model and compare it against another. If you've heard of Firebase remote config, it's a way to do A/B testing and be able to just experiment. So what do you get with the APIs? So they call the base APIs the things that you get out of the box for free, and they're common, mostly image processing tasks that you could add into your app right away without even knowing that it's backed by machine learning. Recognizing text, this is what previously used to be called OCR. An example might be anytime you fill in a check, no human looks at that anymore because handwriting and digit recognition is so good that computers can do all that. So you can add this to your app. It not only tells you what the text it found is, it tells you the location of it. So you can take that little snip out of your bitmap and show it to the user to verify. Or you want to do something cool like Google Translate has a way that it can automatically replace text it's found and translate it with a different one. If you haven't used that feature in Google Translate, lifesaver when you're traveling. Labeling image is slightly different from the classification example I showed you, Chihuahua versus muffin. Labeling is identifying all the things in the picture, which is a slightly more complicated task, especially when it can also highlight the region where it found a dog or a piece of food or like a tree or person or a ball. Face detection, you've probably seen the filters in a lot of popular social apps that adds cat ears to your head or like a mustache. In order to do that, those apps have to figure out what are the salient points on your face, like where are the corners of your eyes, where are your ears. If you're turning, maybe it changes depending on your expression, if you're happy or sad. So that comes out of the box. There's also barcode detection, not very interesting, but that's part of ML Kit if you want to use that. And the last thing it comes with is landmark detection. So for a travel app, you can point it at a photo of the Eiffel Tower, and it actually recognizes it, gives you information from its Google's knowledge graph that says, this is the Eiffel Tower, it was built here, here are the hours. So you can add that to your app also. And this is just what was announced. There's some more functionality coming sometime. Smart replies, so if you've used Gmail or I don't know which of the messaging apps, but whoever sends you a message, you can automatically tap a button that has a suggested reply. So it saves you some typing, and it uses ML to figure out the meaning and what you might want to say. And then face contours, so that's beyond even identifying the coordinates of where the corners of your eye is. It actually draws a circle around your eyebrows or your eyes for even more realistic cat ears and mustaches. Some other attributes of ML Kit. They distinguish between having these features run on device and also in the cloud. And there is some trade-offs between it. On device runs faster. You don't have to wait for the network. You don't have to send your whole high-res picture up to the cloud, wait for the cloud to send you a response back. And in the case where you have no network at all, you can still use that functionality. But the reason you might choose the cloud is that you have higher accuracy and maybe more features. So in the case of image labeling, so that's where you're saying like this is a picture of an amusement park. When you run the model locally, it only identifies 400 kinds of things. So it might not even call it an amusement park or a bridge or an apartment building, it just calls it infrastructure. But in the cloud, that version can give you very specific labeling. And when you install or use ML Kit in your app, you can, the first thing you have to do is the model is uploaded into the cloud. So for the base APIs, those models I think they're bundled with the Play services, so you don't have to like constantly download it. It's just part of Play services. But if you're using your own models, your own machine learning models, you put them in the cloud, and then they can be downloaded on demand. So that saves your user from having to include that in your APK, because not only can you send it on demand, but you can also update it, which is really key for experimentation. I mentioned this already, but you don't have to, if you already have some data science people that have worked on some sort of machine learning model, you can actually install that into your mobile app also. So I want to spend the rest of the talk talking about how to use custom models. So fortunately, there's a whole bunch of documentation about it. This is just a shot of the Firebase console with the new ML Kit tab on the side there. And it's super bare bones. And I know they like to talk about how it's really nice and stuff, but really all there is this big plus button to add a new model. And then when you have a model uploaded, it just has a little overflow menu that you can replace, download, or delete it. That's really all it is. With this console, the idea is that you could upload more than one model, and then in your client app, do A/B testing between the models. That's it. So if you want to get started with this, like I did last week, you can look at their codelabs. Now, the confusing part for me is that there are 3 separate codelabs that I had to go through in order to put together a demo. So the first one is an older one called TensorFlow for Poets. I think this is about 2 years old. This runs completely on the desktop. There's nothing to do with mobile. But what it does is, so there's a feature of a lot of the image recognition machine learning models is that machine learning, if you imagine it as these layers that sort of model after how a brain might work, you have these sort of lower level neurons that are excited by maybe like edges of images. And then the higher level ones might do patches or colors and things like that. And the very high level things at the end can decide whether this is chihuahua or muffin. The idea is that you can replace that top layer and retrain a model that already is excited by edges and colors and patterns and things like that with your own classification, and you give it your own set of images. And you don't have to train it from scratch because it's already optimized to recognize pictures of things. You might want to build it again from scratch if you're recognizing things like line drawings or something that isn't a photorealistic image. So this codelab walks you through how to retrain an existing image recognition model on your own class of. So you need to do this one to build a model to train your own images. And they provide you all the Python scripts to take a folder full of images whose names are named after the classes of things you want to recognize. Now down into the Android world, this one is called TensorFlow for Poets 2, the TF Lite version of this codelab, because there's also one for TF Mobile, which is an older version of TensorFlow for Android. This one guides you through converting that TensorFlow model you might have retrained from the previous codelab into the Lite version, which is one optimized to work on mobile. And they provide you this, the tool chain you install has a converting tool. This is something that Google is going to offer in the cloud soon. They announced that on I/O. It's not ready yet. And then you take this file and you just bundle it in your app. And then you include this AAR, which is an interpreter for the TF Lite model. And then the last one you need, so notice I haven't talked about ML Kit at all. The last codelab you need doesn't have a nice name like Poets. It's called Identify Objects and Images Using Custom Machine Learning Models with ML Kit for Firebase. So in this one, they actually walk you through taking that TensorFlow Lite model, uploading it to the cloud, how to use the SDK to refer to that model, and then use it in your app. So you can actually choose when you're using the custom model interpreter in Firebase whether you to have only a local model, so it's just bundled with the app and it's going to use that one, or use the cloud one. And we'll always prefer the cloud when there's a network. The idea is that you would ship your app with the model as you trained it right on release day, and then as it gets better performance, you could deploy it in the cloud and it would just automatically update. Okay, so now I know how to make an ML Kit app. I need the idea, and this is what I alluded to in the title. It's like, okay, what am I going to do? So I thought, you ever gone to a dim sum restaurant and you're like, what is in this steamer? I can't read Chinese. I don't understand what they're saying. Does this one have meat in it or not? So I thought, oh, what if I could train a classifier to tell apart different kinds of dim sum? So all those 3 codelabs together seems like it would give me all the tools I need to build this. I can retrain that image recognition model on pictures of food. I can deploy it through ML Kit and then use the samples to classify. So that was the idea anyway. It didn't work out. Partly because there were all these different codelabs. My theory now is that the model that I generated from the TensorFlow for Poets 2 codelab is a floating point model. So the input for the image is instead of like an RGB value that's like a hex value from 0 to 255, it's like a floating point number from 0 to 1. And the example in the ML Kit code lab uses just integers. So that's my guess. I don't know if that's true though. And I just messaged somebody who did a talk on ML Kit a while ago, and she didn't get it to work either. She didn't try it yet, but she also did what I ended up doing, which you'll see in a second. And bizarrely, the TF Lite code lab has this cool like live camera interface, whereas the ML Kit one just bundles 2 pictures in the app, and there's like a spinner to just choose between the 2 images, and they're static, so you can't take your own pictures. So like I wasn't able to kind of join them all together. However, in the spirit of sort of sharing what I was able to do, I'm going to do a quick demo. And unfortunately, this demo doesn't use ML Kit. It uses the older bundled interpreter. It uses TensorFlow Lite. So let me set up for that. Okay. So this is seeing my live phone. Perfect. I went to a local restaurant earlier today. I have actual dim sum here. But you can tell this is not like a demo that is canned. So what I did was I trained it on a lot of images. I went out this weekend. I had friends go out and eat dim sum, and I had them send me pictures so that I could train it. I went online and found a lot of pictures. So I know I'm going over time. Okay, so here we go. Tell me if this should be too laggy. So the thing is about image classification is that it's deterministic in that the image goes in one end and it has to be classified as one of the 3 things that I classified. So if I have a picture of the table here, it's identifying that as a hagao, a shrimp dumpling, which clearly it's not. But I haven't trained it on anything that isn't a dumpling, which you would need to do for it to output unknown. Because again, it's just pushing those pixels through and the network just identifies it as something. But it actually does a pretty good job. So here we have, look at that, it's almost 100% on CMI. So that's a shrimp and pork dumpling. And then this one here, this is barbecue pork bun. All right, doing well, doing well. Here we have from the title of the talk, hagao, perfect, 100%. But now, these are things I didn't train it on yet. Doesn't know. It's a little bit confused, maybe, and it's kind of flipping back and forth between things. Same with this one too. What's interesting is that it only is as good as the training data you give it. So head on like this, it identifies a hagao as 100%, but if I start going on an angle, it might not, it might kind of flip to something else. Because so then we did it the other day where it didn't actually, so because I didn't train it on examples that were on taken at this sharp angle. So now this was at 100% on the barbecue pork bun, but on this angle, it suddenly has flipped to something else. So it's only as good as the data that you train it with. That's it. No, you can't have any. This is my questions.
How large did you find the data sets to be? Because if you're including it with your app, that's a tough question, right? Because how many things you're training on. But is there a general guideline as to how big to include, how big of a size to include as kind of your base data set?
You're talking about the training data?
Yeah.
So they recommend for these mobile optimized image classifiers about 100 images per class. Now, the images don't have to be super high res because the networks, the mobile optimized one, the images are only 224 by 224 pixels. And anything bigger, it just crops and shrinks it down for training purposes. And that, whatever you train on is what it can also run the inference on later. So the images don't have to be really big. And the images themselves don't get shipped with your app. It's like once you've trained the model itself, depending on which model you use.
But how does the size of, not the size, but how does the quantity of data that you've trained it, how does that kind of break down into actual size of these model files that it's reading?
So the model size won't change depending on the training data just improves the accuracy of what the algorithm can predict. It doesn't change. The size of the model is determined by the size of the network. And so Google has something called MobileNet. If you've heard of Inception, which is like the really well done, that won whatever the vision competition was, that doesn't work well on mobile. It's huge. It's got millions of parameters. But they have a new one called MobileNet, which is much smaller and results in a model that's only a couple megabytes. Or even smaller. The trade-off is that a smaller model might have poorer accuracy.
Right. Okay. So there's so it's not like huge. It's usually just a couple megs at most, kind of thing.
Yes, but you have to kind of weigh performance versus accuracy. And these mobile nets get impressive accuracy compared to what Inception can do, and they also work really well. So this was doing it almost at 30 frames a second. Like it can actually analyze the image really fast, where you probably could not do that with Inception on an older phone.
Right.
Like, how many images did you end up like using to train this example?
Am I still sharing my screen? I still am. So to kind of comply with licensing, I tried to use images that were Creative Commons licensed, and I ended up with about 100 images for each class. And so a nice tip that one of the Google developer advocates has is that take videos of whatever you want to train on, and then slice it up into still images, and then move the camera around because you get different lighting, you get different angles all in one go. And then if you can script something like Flickr or even Unsplash that has an API or Pixabay or something, you can get a whole bunch of Creative Commons licensed images and train it. But this is a general problem for all sort of machine and deep learning practitioners, is that where do you get all that training data from? You gotta have to do it yourself or pay to do it.
You mentioned an integration between remote config and ML Kit. Does that go deeper than like just testing different models, or?
That's all you can really do now. Is basically the remote config gives you back the string, literally, of the model that you uploaded, like which one of the two or more that you've chosen.
Okay.
Yeah.
When you're creating a model, like you don't have to set any parameters yourself. You just start like feeding images for different classifications. Is that correct?
Yeah. So the codelabs walk you through how to retrain an existing MobileNet model. It's beyond the scope of their codelab about how would you take another model that you read about in a paper or somebody else's model and get that to work well on mobile, because many of the models may not be mobile optimized.
Okay.
Cool. Thanks. Oh, sorry. Well, I can. Go ahead.
How hard is codelab for like machine learning experts? Because like most of us are just developers, and it's very hard to get the grasp of AI concepts, like machine learning concepts. How easy it is, or how?
I don't know that I have much of a head start on the truth. I mean, I did take some courses, but the codelabs are pretty well written, and Google also has, I think it's a nano degree in a crash course in machine learning that they're kind of promoting. That can give you a lot of the terms that help you understand. There's quite a bit of TensorFlow documentation too, but I found the codelabs pretty straightforward because they actually tell you like, take this snippet of the code and do this, or like, put your images in these folders with these names and run this command. So there's not really anything. The codelabs really hold your hand through the whole thing. Okay. Okay. Thank you. I'm going to put on my like.